Recording is on.
Welcome everybody to the second office hours AMA in the cohort 7, the EPF. Today we are joined by Tamaghna, Razor client, who is an alumni of EPF 6. So another fellow who has already completed the program and is continuing to contribute in a number of different ways across the ecosystem. Maybe most notably currently as an intern at the Ethereum Foundation for the Steel team, the specs and testing team. So yeah, thanks for joining us today, Tamaghna. We're going to have a rare occurrence here where I am going to host this call because Mario is in an airport. So please bear with me as we go through this. Yeah, so thanks for joining us. First question I wanted to ask you is just to give us a little bit more insight into your background and like what brought you to Ethereum, what got you into the fellowship, like what sort of things inspired you to start contributing to this open source project.
Oh, sure. For an introduction, hi, I'm Tamaghna. I am currently in my fourth year of undergrad, computer science. I'm based out of Kolkata, India. Um, so how I got into Ethereum is a pretty fun thing. Like most good things in college, it started with a hackathon. So in my hackathon, there were a few judges, which coincidentally were also EPF alumni who were working at the Nimbus team. So when I met them, I talked to them. Like at that point, like I was in such a place as an CS undergrad. Like I knew stuff, but I couldn't let's say pinpoint what I'd be working on. So I talked to them, and I felt like, hey, this seems interesting. This is pretty fun to work at, and also another thing that actually drew me was it was this kind of thing is moving pretty fast. Like for cryptography research, etc. Like when I've seen in normal, like it generally moves at a iceberg pace, but like over here, the rapid iterations were something that I really liked. Like something like I personally like is to move and break things fast and make them again, and like however on a very concise way and without in a sloppy manner. Like with AI now, that's also a very big problem. So that is something that drew me close over here, and then after that, I started looking into stuff. I was interested into the architecture, how such a big system works in itself. So that is in general what brought me. Then I started trying to contribute. I started looking here and there. Hey, this is there, this is there. I worked in a few, let's say, ZK jobs, etc. And then I was like, all right. And then, just like I said, my previous cohort alumni also gave me the EPF wiki. I looked into it. I was like, this is a very cool consolidation of the Ethereum protocol information. And I went through that. I came to know the program. I applied, and then I got selected. So that is a brief intro into how I came into be as a fellow.
Awesome. Thanks to Magna. And yeah, so love to see like how your project progressed through EPF 6. You were responsible for implementing some of the bits of Pure ETH and Nimbus. And yeah, now as like an EF intern in the Steel team, curious like if you want to give us a little bit more information into like what like specifically you're working on these days. I know you submitted the project for having fellows work on Pure ETH this time around, so acting as a mentor for that in the Nimbus client, as well as like what's going on with the testing team, like what sort of responsibilities are you taking on there?
All right. I'll start with my current work. So right now, as the testing team, I have been given the gracious opportunity to, let's say, coordinate the work around the SSD engine API transformation. Like all of you have might, I guess, if you have gone through, you know what the engine API is, and also you know that it's currently in JSON. And like what happens is JSON, because it's a hex string and like it's very heavy. Like we would like to move it from, let's say, to a binary format, and the binary format that is going to be used is SSZ because SSZ is something that is already native to the CL, and the EL will be introduced to it through this. And other than that, I've been working on a few other areas, mainly a few EI. Like one of my another jobs is to prototype a few EIPs regarding blob scaling, post-quantum blobs. Like that's all. That's a work in progress. Not very quite there yet because I've mostly been working on the engine API part. Um, in the fellowship for peer read this time around, what we're looking for is more implementations other than Nimbus. Let's say have a flexible DevNet, etc., and uh, and to have them test around, we would like to see implementations of both the ex- SSZ execution block and also the trustless log index. I do know the log index had a UR which is basically an improvement of the 7745B proposal, and so would like to see implementations coming up and guiding them. Also, uh, like I discussed, there's also another project which is the SSZ query language for the CL and the EL. This is a bit of tricky part, so like that's there. So like maybe regarding this one, we can have a chat in the DMs. So yeah, so like majorly from where I see POI/PRS is important is two parts: data availability basically when data availability as per se not for the blocks but for the user side, because how all of us interact with the blockchain is through the RPCs, but because the RPCs are generally just sending you anything, like Infura can today start sending you junk and you wouldn't know if it's you are being poisoned. And the surprising part is this kind of attack recently happened with the Layer 0 attack was basically an RPC poisoning attack. So the idea is to transition the execution block structures into SSZ so that we can have the normal SSZ proofs which are rooted at the execution block, so that the all of the RPCs have SSZ proof attached to it, which you can verify in your browser running a live client. And so that's the basic idea of how it's to me. So that's the basic idea that would be happening. Other than that, also because it's also some kind of tech debt, I'd say, because SSZ was a invention that came out around ETH 2.0. So the execution client was supposed to move to unified encoding, but that is something that has not happened yet, and that is something I'd like to see because of both, like I said, it's just like it's easier, and also because of the RPC access and etc. So that would be brief introductions to both sides.
Awesome. Thanks so much for that. Yeah, let's have some questions from the audience here. Go ahead and raise your hands when you are ready to ask a question. Otherwise, I have one more for you, and that is um, like touching both sides of like the implementation and now like the testing side of things. Like how do you feel like you approach these things differently? Like what sorts of considerations do you have to take when doing something that's more on implementing the feature side versus like testing and trying to make sure that everything's going to be safe and do what it's supposed to do?
So basically, from what I see as a test, like when working on the testing, it's very important to have a very descriptive testing and like let's say test everything that might occur, any kind of let's say attack vectors, etc. All of these things need to be taken into account. Let's say edge cases, etc. So it's more of a work that is very descriptive per se, and like you need to have a very good fuzzing, etc. These kind of things are something that I'd say on the testing side is very important. However, on the client side, which I think is more important, is because writing, let's say, tests or Python is basically a generator, but writing a client is something that will be used in production. At the end of the day, tests are not something that are going to be used in production, but it's just going to be used to verify the production. So writing production things, a lot of other things come into my code, code clarity, etc. should be there. But I'd say like coding patterns do change from languages to languages. Working with Nim, whoever wants to do it in Nimbus, will the other things in Nimbus, you see that working with Neem has its own caveats. This would be the same for, let's say, writing in Go, some other stuff like how they like the code to be maintainable for, etc. Also, speed matters when you're writing lines, etc. So this is very important. In general, writing client code is uh, per se uh, a bit more hectic, I'd say, because you have to test it again, then you have to run uh, you have to run simulations, etc. So that's there. So like, yeah, that's what I'd say.
Yeah, great. Yeah, let's hear some questions from the audience. Go ahead and raise your hand with a question for Tamagna. Awesome. Skaz, go ahead.
Hey, yeah, I have a quick question about the trustless lock and transaction index. Seems like a couple of days after published new AP with presumably the better way to do it. It's A304. Can you elaborate a bit? Like, I saw that 77545B is on the project list and you suggested it there. And I wanted to ask, like, what's the current state of art with both of these?
For 7745B, there should be a get implementation from the author. From the newer one, the get author was working on it. There is apparently a branch, but it's a bit dirty. So, what I provide from my side is I try to provide a Nimbus implementation per se for you to test it against, because not sure how much the it would be done in get. So that would be there. And also, something else that should be worked upon is, let's say the process that is shipped on a DevNet. On the user side, there should be, let's say, a small library that uses that and tries to verify all of the logs. So that's what I'd say. Um, for the design per se, like this has been going on for, let's say, a year. Like I have 7745 worked on it, gave implementation. These parts is something that are lacking, this needs more work. So it has been a process, and like this one is the most newest implementation. This one is also an implementation that say would be good with the ZKVM, or let's say the history proving part. But like yeah, so like that would be a more of a work throughout the cohort, getting implementation up, uh, getting maybe if you can, if a few more fellows work on it, a testnet up, and then let's say having a few client side, client as in user side uh, examples per se, or like libraries to test it again. So like yeah, that would be a good explanation. Do you have any further questions regarding
No,
this?
actually, yeah, I think that'll be more than enough. Thank you for the heat on the library, because I was also thinking about that, how to make it accessible to other teams. Yes, thank you very much.
All right, who's next? Don't be shy. All right. Well, while we're waiting for people to conjure up some questions, here's one more for you. Curious about your experience going from like working on a project during EPF to basically mentoring projects one cohort later. Like, what's that experience been like for you? What's it been like sort of integrating into the Nimbus team as an independent contributor? And yeah, just talk about a little bit more about like the transition from EPF to independent contributor.
Sure. I'd like to start with the Nimbus team is pretty helpful. Deme, Ethan, Tursek, Agni, Advaita are pretty helpful people. So let's say moving from the cohort, did meet with them in Buenos Aires. It was a great time roaming around with them. And after that, so what I did was I looked at the EL implementation. I saw that they were less in the EL implementations. It's already a very thin team. So like what happened is they couldn't, let's say, they couldn't test their implementation. For the RPC, the RPC was very bad. Like it was around out of 200, it was 20. So after the cohort, I grabbed that. I started working on that one by one, knocking items out of the list. So right now it's still bad. It's like around 60 out of 200, and like there were new test, RPC endpoints which were introduced, but like yeah, so it's better if we have the each simulate V1 that would be increasing the test scores very bit because 100 test scores were around for that, but like that is something another person was working on, and how that guy is also working on the Val DevNet, so like that's something he's pretty locked up with. So that would be done there. So that would be a moving from let's say EPF to an independent contributor. In EPF, in this client teams were pretty good. I'd say Ethan was the most helpful guy over there. Ethan would help me a lot because when I started it, right now I'd say the progressive container support in the SSL library still exists. But when I started working on it, it wasn't there. It was just an idea. So when I started writing the progressive containers in let's say nim each, so what happened was I used to get a lot of nim build problems because and then later with Ethan I diagnosed them. There were errors also because Nimbus uses something known as the Nimbus build system, which is pretty different from the normal package manager, which is Nimble. So that was pretty hard. Like I had to get all of the sub vendors, then inside the sub vendor directory, I needed to move into the sub vendor directory. Inside that, the name it inside there, I needed to work. And then because of this sub vendoring thing was happening, if let's say I missed one or two steps, the name cache would get corrupted and everything would have to do from again, upgrading the sub vendors yet again, etc. I fixed it. The first thing I did was this is too painful. I'll fix this. So I fixed that in SSZ, the name SSZ implementation. Then the progressives were broken. I fixed that with help of Ethan, of course. And we had a lot of time. Let's say, hey, this is broken, Ethan. Can you have a look? All right, sure. Then he was like, yeah, this is fixed. Oh, this is also breaking. So like that was the thing that helped me a lot. And then when let's say I moved from the SSD things to Nimbus ETH1, so the transition was very smooth because I was already habituated writing name and stuff. Moving from a fellow to a mentor, it's pretty fun because just a few last November I was amongst few people. I was presenting it in Buenos Aires. I worked over there and like I gathered a lot of important experience which I'll carry forward even after let's say my time at Ethereum or even after each code dev stuff is done. It was very important for me to let's say have such great mentors. So and also like during my fellowship, I did understand like, hey, this is something a fellow might need during his internship. This is something so like that is also something I try to keep in mind while giving the project and like helping people out for the project, mentoring them. Um, um, and I'd like to thank Ethan himself because like he's the one who said, "Hey, this time maybe you can take the lead on this one because you seem to have the more information regarding the EL, the different parts. So like, and also you would be the one who would be giving more time to the fellows on this project. And so thanks to him, like I can't stop thanking him enough. He's a very good friend now, and yep. So that's this. So like I talked with Ethan and I was like, hey, we need to let's say, give it this time. And Ethan was like, sure. And I pushed him, and he was like, yeah, this would be great to have the projects and implementations. And then we were like, who's then let me be a mentor to? I'll be helping them and wherever they need. And they were like, maybe you can do this stuff. And I was like, he helped me become a mentor too. Yeah, so like mentoring hasn't yet started. Like a few of you have been reaching out in DMs and talking about stuff, and like I'll be happy to help you all. I do see some of you guys here. So yeah, that's small. That's not small. So like that would be a brief about everything. So like it's been pretty great moving from a mentee to a mentor. So
Awesome. Yeah, we love to see the both the like transitions from fellow to whatever happens afterwards, and really it's super special when somebody comes back, especially so quickly, to come and be a mentor for the next cohort of fellows. And additionally, like watching the relationship between you and Etan bloom, and just like how the closeness that you guys have developed and the way that you work together is also really a special thing. So um, yeah, making magic over here in EPF. Who's got some questions for Tamagna? Maybe some of you that have been reaching out to him about working on the Purity project. We got Mohit. Go ahead.
Hi, can you describe a bit more about testing? Like testing requires you to look into a lot of directions at once. So, any tips about that?
regarding testing, like, can you just say
Yes.
once more? Yeah, testing. All right.
Yes.
Um, so yeah, this is something that is true. Like testing does require you to look into a lot of directions per se. So something I like to do while doing this is like having a concrete list per se key and sub lists. So like, hey, get a tester head, get this thing, set slot, etc. These are the things I need to cover. Then inside these might be the things that need to go in. And then let's say in testing, like generating test cases, like this is something that even I was talking today, right now, right a few hours earlier, this was something I was discussing with my mentor at the year, that the execution spec randomization is not something that is we'd like. So we're also working on that. Even for the SSL engine API, that is something he has asked me to work on. So it's an evolving process. I'd say selecting a point, knocking it one by one. Like also this is something I personally agree. Like while working on a project, it should be the ERs themselves should be atomic. Why? Because it helps you in two things. You can, in your mind space, it's like, hey, these are the things I'm working on. So maybe in this PR, this is the stuff that gets fixed, this is the stuff gets added. And also because it's easier for the reviewer to review. And so like atomicity does help me a lot in, let's say, keeping a distance of these are the things, this is the blast radius. For this exact bullet, this should be the blast radius. So that's what I'd say.
That's good. Good.
All right, come on, people, don't be shy. Let's have some nice questions for Tamagna. I'm sure Connell's probably got a question for you somewhere. Connell.
Yeah,
Sorry, you
I have
can.
a question.
Yeah, go ahead.
Yeah, I'm just curious, like, how did you go about deciding which project to move ahead with? I'm between two projects at the moment, and they're both pretty enticing. So just curious how you sort of narrowed down what you were interested in, and yeah, what sort of edged it for you. And also, curious to know, like, did you end up working on this your project with people, or did you go solo and just build yourself? Yeah, thanks.
All right, so like project P and stuff. Yeah, interesting. So, the first thing that I'd say while selecting projects is understanding the scope per se, because some things require more effort from the client teams than other. Let's say EPBA, if nobody has, if let's say last scope of EPBS was something that some of the clients had given. So when we're working with EPBS, the thing is the client teams will also be working with them. So will you be able to match their speed? Will you be able to help them properly? And the thing is, the closer, let's say, the feature is to getting to mainnet, the more the client teams will be engaged. Like even for Fossil, like for Fossil, what I'd say is for any client team who is working on Fossil, they already have someone who is dedicated to look into the stuff. So how would you be helping them? Would you either be, let's say, because this is something that you would always need to take into consideration. You would need some time to get habituated with writing the programming language, the code base per se, their coding styles. So how fast are the deadlines? How fast can you, let's say, understand everything? How fast can you contribute in a meaningful manner that isn't blocking them? So all of these things come into play, and also something that I suggest on a personal basis that is also something I did is some projects per se are more exploratory than others. So the scope isn't bonded down per se, and this would actually help in let's say you having a bit more freedom into look into stuff that you might like. And like what happened is during Pure I worked on the clients. I did also work on Steel because in Pure we don't have tests in the Steel. So like that is something I worked upon with I couldn't complete it during the, but like that is something I did work upon. So having some sort of freedom and some sort of guidance is something very important. And on another major point being is how much bandwidth the client team itself has, because they also have work, they are bogged down with work, they have deadlines on their own. So let's say how much will they be able to help you, etc., etc. So that is something important. And what was the final part of the question? Can you just say again?
I think you kind of answered most of it there when you're going through it. I guess the other thing was like, did you collaborate on your projects or did you go solo? Like ultimately, just piggybacking off what you just said there. There's two projects I'm looking at. One is probably closer aligned with my interests and more relevant to what's about to ship on mainnet. But the other project potentially has some more like learning potential. It would involve like more like sort of Rust and execution client stuff, which I haven't gone super deep on before. So I'm having a hard time deciding what would be the better call. And also the what I'm more interested in will probably be a solo build, which might be better for projects. But yeah, very curious to hear like your thoughts on that and if you collabed on your project.
Yeah. So yeah, I did like this is also something I was going to tell later. The scope of the project did, like I said, when you start looking into the project, you'll understand how much work needs to be done. And like what I did was I took into account that hey, I have 3 months to do coding, and in that coding I need to have a finished demo at the end of the presentations. So what all can I deliver? And also like something you need to take into account might be if anybody else wants to work upon them, if you do seem that hey, this is something that might be helpful to have someone else on. I did work with somebody. So during my cohort, I worked on the SSZ execution blocks, and beneath was another fellow who was working with me on the fastest log index. So that is how we did it. We divided the work cleanly. So this is also something that would be important if you're working with a fellow. A clean division, so like none of you block each other, but like instead you both are helping each other out towards the end goal. So that would be very important. And it generally depends on the project scope per se. Some projects have one person can pull it. Some might need two, some might need more. So it's more of project to project basis per se, and like how much work you would need. So yeah, I on the last like what you'd like to go, I'd say go on which one you're interested. That is something you'd like to work upon, and like that is what I did. So like yeah, and like also learning is very important. So like all of us have always something more to learn. So yeah.
Yeah. No, that's great advice. I like your advice about the sort of how you distributed the work when you're collabing. I think that's super important. Um, yeah, it's just a tough call. I'm kind of very close to two. I think I might go for the one I'm more interested in, even if it's like maybe not like the one I would learn the most about necessarily. But might be the one that I'd have like the better sort of demo and deliverable at the end. So that might be the cleaner one to go for. But yeah, thanks for your advice. It was super interesting, very helpful. So thank you.
Sure.
Thanks, Chris. We have a question in the chat from Connell. Do you think that the direction of client development in the future will trend closer to something that resembles high quality reference specs and formal verification rather than the security through redundancy that we have across the clients currently?
Nice question. So I'd say this is a bit controversial, but I do believe that high redundancy is something, because here is what I believe personally. Like, once you use AI and let's say formal verification, um, a single bug will be replicated all over. However, if you have six different people working on a feature in six different teams, there is a very small chance of this let's say being done in every other place. And also the things with formal verification which I have seen is, as far as they like to say that it's mathematically correct, it generally has flaws. This is something I did see with FCR. So like once they were like, hey, FCR is formally verified, we can just ship it, let's have a client. And then so this is also something Ethan worked on. So Ethan used to complain a lot, like, hey, there is this cases which you're missing, this is something you're missing. So having people working on it brings more eyes into it, and these kind of things that people or AI generally misses something you have a lot of eyes on, and then you'd be something they did someone will be, not everyone can give their 100% every day. When somebody is, let's say, giving their 80%, they might come across and be like, wait a minute, this doesn't seem right. So always that point is always there. High quality spec reference is always better. So like, however, the spec is in generally written in such a manner that you understand the changes that are going to be done. You would internally need to, let's say, implement the caches, the data structures. How will you be handling, let's say, the chain DAG? How will you be handling the blobs, the blob quarantine? What will be your algorithm for it be? What will be your algorithm for syncing? How strong do you want syncing to be? How let's say decentralization, like decentralized checkpoint sync. These are things like which comes once somebody has a very good understanding of the and deep understanding of what they're working on. And so like once you move away, like the spec is written in a manner that leaves implementation opens to people who are implementing it. So like having only somebody who just looks at the specs and just implements it, like code monkeying type, is not something that I personally recommend, because I do feel that the human touch to it is always important. Yes, of course, like AI, like this is also something I believe personally, AI should be used as a tool and not as a replacement, because humans are humans. They're whatever they have, their cognitive ability will always be greater than any uh, next word token generator, which AI basically is. The current LLMs are just auto-regressive models. They just look at the text corpus and generate the next word. So like this will never have the capability itself to think for itself. So that's something I would like to say. To add the
Cool.
point of security, where we kind of get thrown around everywhere today, but it's limited. Since high beacon quality spec, even Lean is having more client implementation than Beacon right now, not planning for a single. Yeah, like Mario just said, like, yeah, like this is also something very important. Like, as much as formal verification is said, formal verification isn't that strength. Like if you have looked into mathematics, you'd know like even in the mathematics logics there are holes, and like that is a very established thing. Like the very idea of the question that Turing answered was like mathematics by itself cannot always, or it's already bounded on like it cannot always answer every question. So like using final formal verification for something is not the answer person, especially for high critical systems like Ethereum, because like Ethereum is in itself a very secure system just because of the moving parts that it has. So like in such a system like this, just moving towards AI and formal verification and just saying, hey, it's okay, it's not the way to go. It's something I feel.
Nice. Uh, there is a follow-up here saying, how do you think this will play out as we verge closer to ZK EVMs generally? Won't it be necessary, for example, to implement only 2 to 3 EVMs? For proving sake, won't it actually be more dangerous to redundantly re-implement things?
All right. So EVM implementation. So like it's fine to have an EVM implementation in, let's say, every client and like every language, like that's already there. Like, so the Thomas from the post quantum team started writing Zig by implementing the EVM in it. So like that's something very understandable. The thing that is very important is these kind of things in general have security bugs in them. There might be memory leakage. There might be things that might be, let's say, uh, some things they are missing. Like I don't know how long have you been in crypto, but like the biggest ZK library that is used to be used was Sarcom. Like it's not so much used per se, but like there were a lot of high critical bugs found in Sarcom's over its lifetime. So like that is very important to have multiple implementations, because a bug that comes in one implementation would not be there. Like let's say how even from memory, like even for memory, I'd say different languages have their own different structure of how memory is managed, how the GC works. Rust uses ownership, etc. Then NIM uses the GC. Zig uses allocated, like allocated internally does everything. So it's a nice interface to have around. So this is something I'd say. And a RISC-V ZK review from proving sick. All right. I don't know how if you have been seeing, but like it's the same. Like security bug arises in the ZKVMs too. Is this third one? What else comes to mind? I mean, in general, I have seen every ZKVM have certain kind of use. So like till maturity is like availed in ZKVMs, and like they have been used a lot. So that's the thing. And like these proofs by themselves are mathematics and code. So like code can always be wrong. There can always be some kind of timing attack or like any kind of cryptographic attack can some be found, let's say. So that's always the problem with these kind of implementations. But like I'd say like having some diversity is better than having no diversity. But like to re-implement, yes, like having redundancy is pretty dangerous. So like it would rather be to have a few ZK and a lot of EVM implementations. So yeah, that's it. So like uh, next
Cool. We'll
question.
just say one more from him to round this out is um I think he's saying what he means is that actually the ZK events by definition are proven to be quote unquote correct. So implementing them more than once seems like it might introduce additional risk rather than redundant security. Any thoughts about that?
Um, Uh, Good question. Let me think about it. ZKVMs by definition are proven correct. Yes, I mean the maths behind this is pretty solid. Yes, of course, like it's pretty solid. Like this current ZKVMs, CC, Fry, and etc. But the thing that I would be the most into is already have had their security vulnerabilities. These have bugs in them, and these are found day by day. If this is being shipped into mainnet and somebody exploits it, it can be billions and millions of dollars of loss. So having something that is proven correct will never work out because, like I said, mathematically there's always holes in the system. So like you can never fill them in its entirety. Um, Proof generation, like the pipelines itself, are something robust, but memory implementations, etc., memory leaking, then they might find some kind of bug that, uh, let's say, the proof is being opened by some kind of bug they found or some security vulnerability that might exist. And like, also, this is something that I do believe. So cryptography is generally never safe. This is something that is also, I do believe, I'll tell you the reason why. There is no proof per se that this cryptography that we are using is something that is not being be able to break. Like before quantum computers, we did think that electric currents was something that we're going to outlast. But what happened? So like because it was the new computationally hard NP-hard problem that was taken at the discrete log. However, as technology advanced, it became breakable. So why is it not that maybe someday some technology comes and says, "Ki, hey, the PIOPs or the IOPs that we are using have holes in them, and maybe we can exploit them." So then that would be catastrophic for everyone. So like, what would happen then? That's something that is a very open question. Like even uh, so always cryptography, lattice cryptography, hash-based cryptography, these are thought to be solid till a hole in them or till any kind of, let's say, uh, fault in them is found. At the starting of Clean, Poseidon 2 was a very big, let's say, thing that everybody wanted. But on further cryptanalysis, it was found that it's not as sound as we originally thought it to be. So what would happen then? You would have implemented something on, let's say, Fry or even Word. So then later somebody comes and says, hey, inside this, you can maybe exploit this kind of, this part of the Word protocol where the wrapping is done, or maybe in this part of the protocol where the fiat shamir is something that is the if you have seen into cryptography, fiat shamir transformation is used for transforming the random uh, problems into, let's say, one is to like they just use the hash of the inputs and use and take that as the random values, because random values need to be used in cryptography. And somebody comes and says, hey, this inside this fiat shamir implementation, I can maybe exploit this, and the entire loop is broken. So who is saving you from that? Nobody is going to be saving you from that. What do you do? So like that's important.
All right, thanks so much. Um, Next question is, how does the ZK work that you did in the past, how's it been helpful for the work that you're doing now?
I'd say it had a okay. Here's the fun part. I haven't worked with ZK in the I don't work with ZK in my day job, or I haven't worked with ZK, but like I do have an understanding of it, and I do see, let's say, the ZK VMs or the directionally where Ethereum is headed. So like I have an internal understanding of what is happening. That work hasn't been very helpful to me because that is not something I worked on. I chose to work upon this. If you do choose to work upon, or if I had chosen to work upon ZK VMs or Lean VM, etc., it might have been helpful. Like I do, I did went into pretty deep into when I did that. Uh, over a small prime field, I worked out examples with hand of how, let's say, the Groth 16 protocol was working. I wrote an implementation of the Fry. Like if you know, Fry is the basically the scheme that is used for a lot of these ZK VMs. I do hope that's the case. I don't know if they have moved into Word, but I don't think so. So it did help me into understanding, and like these kind of things always help you into understanding. And the work I did in ZK per se was just writing stuff from circuits. So like not very helpful, but like yeah, like it always helps you in having the idea and things.
Awesome, thanks so much. Next question from the chat. Looking back at your EPF experience, what was the biggest challenge you faced? Something that you didn't actually expect, and how did you end up getting through it?
Uh, okay, good question. Man. Like this is something like one part was do keep checks if you are working with somebody. Do keep checks on, let's say, what they are working, how well they're implementing stuff, because you might need to give them a bit of push. This is something that came back to bite me later. And second part is what I'd like to say is challenge you face. Okay, so while working with the client and implementing SSL execution logs, the challenge I faced was there were no tests and there were no other clients which had implemented it. So I was left in a very weird position that I have an implementation, but I don't know if it's right or wrong, and it still might be wrong because I don't have anyone to test it against. So like you would only know that something's wrong when you run it through a DevNet. You read the logs. You're like, okay, this is something where both of our clients broke. Let's debug this, and this is something that caused problem, and this is like I didn't face this challenge, but this is a challenge that mentally blocked me around. Like saying the PureEarth project in itself was down. Anybody else who comes it can do it. So like that is the biggest challenge I faced. While starting, I didn't think testing would be something that would be big. Like I was thinking, like, hey, writing the code would be something that is going to be very uh, problematic. But like these are some things we'll learn. But like the lack of this testing and other clients implementing the DevNets is something that becomes a problem when implementing these kind of features.
Awesome. Next question from the chat. So I'm looking into taking up the SSC execution blocks project. A couple of things that I wanted to ask, like which EL clients do you take SSC execution blocks implementations in during this cohort? And would you recommend RETH, or is another client more needed right now? And are there any clients you're already in touch with or teams already putting effort into implementing these things?
All right. First and foremost, like the thing that I like to say is choose a language you are comfortable in. So pick the language like you have. If you are good in Java, pick the client that is written in Java. If you are good in Go, pick Get. So, like that is something I like to say. Like you will already have a head start over there. That is very important. If you're going good in Rust, of course, with Reth or each anyone, the client, go talk to them. The one that you see he might be more helpful. Go through there. Are there any client teams you're in touch with? Because this is an exploratory project and this is not something that has been included in the protocol yet, client teams don't have enough people to have implementations on this. Um, so that's another reason of asking the fellows to do it because we would not want the client teams to invest their time doing something. They'd rather be doing something that is closer to the fork. Let's say implementing valves or implementing frame transactions. That is uh, writing things, testing things, getting the reviews is something that takes time. So you don't want to take time away from that. So no team just per se has any effort per se. Um, yeah, so like I mean, in general, in the when it's at the EIP stage, you have a POC, and the POC is delivered. Then you go through deliberations in ACDE, ACDC. You debate with other people, which will be the one that will be included in the form, and then the work regarding that starts every year. So that's generally how something moves from an EIP or an idea stage to this to the let's say inclusion. So here is something that you guys would like. EPDS, the current protocol feature that is being worked upon was something that was actually worked on during the cohort by a fellow back then who was Protus, and the Protus then went forward and kept pushing it forward before it was accepted into the protocol. So that was how it started out and the implementation started out. So yeah.
All right, thank you. Any final questions here for Tamaghna? Go ahead and write in the chat or raise your hand, preferably.
Hey, I'm sorry I did not raise my hand. Just wanted to chat a bit as well. Thank you guys for doing this. I was just wondering, maybe before we finish, like, what is some realization, some aha moment you had during the cohort or after, like something that you learned along the way as a fellow, and then transitioning to contributing more long term. Yeah, wondering like something that you learned and you can share with the fellows.
Something I learned is communication would be something that is I really learned during the fellowship because talking with, let's say, you talk with 4 to 5 different people regarding this feature, this thing, in technical terms, like these things is something that I really learned during the fellowship. Something else I learned is project management, how I sort things out in time, how much time this will take, how much time do I need to implement this, etc. is something also I learned. Um, uh, this was also like my third-ish official work that I did, let's say per se. So that was also that helped me in, let's say, what really helped me was, I'd say, my code style, how I write code, how I think about code. Uh, See, like Ethan is a bit very stingy about code writing, about the spec, about securities per se. So that is something I inherited while working with him. So this is something that like the good things that I have learned throughout the fellowship, and help from mentors, help from others, communication, uh, code thinking, thinking about it, thinking about things, thinking about yeah, so like that's some things I'd say I learned a lot. I also learned writing nim, which was very fun, because nim is a language which is not generally very much used per se um, in any other place other than IST. So running nim was a great experience. The language itself is pretty fun to write, but like it's not that popular. So like I would have never learned that whether it not have been the fellowship. So that's something I also writing them did what writing a lot of programming languages will help you understand is how to think beyond programming languages. This is a question that I've seen, and also a problem I've seen a lot of people face, like I like here like what I there's a pretty famous meme of the bell curve, like at the two ends, like I know all of these languages, I know all of these languages. So this is something I'd say, like something thinking about things in a language agnostic manner while writing it down is something that I have also learned. So that would be all of the major learnings. Yep.
Yeah, thank you, Tamaghna. That's great to hear. Yeah, maybe we can have another question.
Yeah, if not, one final question from me, and it's maybe related to this and maybe quite a little bit redundant, but is there something like a piece of advice that you might give to yourself, like as you were starting the cohort, something that these fellows who are just embarking on this journey can take to yeah to help them along their way?
um, Take your time, do not rush into things. Think in a very conservative manner about the implementation timelines, like before saying, okay, I do this in 2 weeks or 3. Think like if something comes up, like always think in such a manner that's, let's say, in a negative sense, because like you need to have a backup for everything. Think in that manner while writing the project proposals and the timelines. Also be very uh, what's the right word? Be very vigilant about the person you do decide to work on the project with, because that might make or break your project. So, like getting a vibe check with them, capabilities, etc., is something that would be helpful. And also, communication is very important. This is something I lacked at the beginning. Like I say a lot of things to Ethan, but I see that he didn't understand what I meant to say, and like working upon that would be very important.
Awesome. Thanks so much, Tamagna. Here, one last question from the chat. What do you think made weekly updates stand out? Good links, cool diagrams, good visuals added to the write-up, playing around with how to make my write-ups more clear and more engaging.
Um, Something I always like to do is be on the point. Don't beat around the bush. So yeah, if you can add visuals and links, that's pretty great. The commit links, let's say, you might not be raising a PR every week. The commit links, let's say, what is the diff you worked on? What is the problems you faced? What were the learnings this week? Um, if you want to add visuals, like I'd rather say not having visuals in your uh, get the week to week things, because that's just bluffs it up, I'd say, for a weekly report. But like having it in, let's say, the presentations you do or the project proposals, then the presentation would be very important to have. And clear architectural diagrams is pretty important. That helps you a lot, let's say, later on. And yeah, being clear, being precise, um, and also not using a lot of AI because it just bullshits a lot. So like using that properly would be using AI properly is very important. Like I used AI, like I used to like something I really do is I type out really fast. So like what happens is I have a lot of spelling mistakes. So like I have been using AI very much to get rid of those things. So that's important. And yeah, so like that is what I'd have to say.
Yeah, it's pretty funny nowadays that I like look forward to a spelling or punctuation or grammar mistake. It helps me to realize that, oh, this person actually took the time to write it and didn't just feed it through a generator. So I think that is changing. Even looking at applications, I'm like, oh, there's a misspelled word. Great, this person wrote that. It's like proof of human. Cool. Well, thanks a lot, Tamaghna, for taking some time to chat with us today and for all the work that you're doing, being mentoring people through this cohort. Really looking forward to seeing what happens with the Peer ETH project and of course, with your time in the Steel team. So thanks a lot. And if you have any other questions, maybe for Tamaghna in the future, he is in the Discord server. So you can tag him at Razor Client, and I'm sure he'd be happy to answer and help out.
Thank you so much for having me. Like it's pretty great coming from the previous cohort into this cohort, and like I was on your side. Like I used to watch these calls with a lot of people from my previous cohorts, researchers, and like it's pretty great to be here. Thank you so much, Josh and Mario, for giving me the opportunity to be part of the previous uh, cohort. It was a great experience. Like I remember it for my entirety of my lifetime. Like it was also, let's say, first time I worked with a lot of people, so that is something experience I never forget. And uh, thank you so much, Josh. Thank you so much, Mario. Cannot stop thanking you guys enough for the support you provided during the fellowship, the different advices you had, etc. So thank you a lot.
Yeah, my pleasure. All right. Thanks, everybody. We'll see you next week for a stand up on Monday.
Thank you, guys. Thank you. Thanks a